Hello and welcome! I see we have Eli, Sammy, Nick Official, Alley Cat, Melanin, Carly, Ryder. It's good to see you all, and I'm seeing lots of correct answers to our warm-up problem.
Yes, indeed. So glad to see that.
Cynthia says x times 2 plus y times 4.
Good job, Cora.
So many other students that said the same thing. Nice work, everyone.
That's right. And we'll solve this and then we'll do a quick introduction. All right, so on this one, X people and Y dogs, well, each person has 2 legs. Each dog has 4 legs. So the answer that we're seeing is 2 times X. So you double the number of people, plus you do 4 times the number of dogs, and that will give you your total, 2X plus 4Y.
That's right. And by way of quick introduction, because this is a sample class, I'm Science Mom, this is Math Dad, this is Kaladin, also known as Science Puppy. Lopin, our math puppy, is right down there.
That's right. You might hear them a little bit in the background. And yeah, super excited for this lesson. Now, for context, this is something that we'll be doing in our Algebra 1 class, which we're super excited about. However, this lesson is one of the few preview lessons that were available to us. They wouldn't let us just use any of the lessons in the curriculum. And that does mean we're kind of jumping into the middle of a unit. I'm pretty optimistic that we're gonna do okay, but just so you know, this isn't the introductory lesson. We're actually several lessons in, and hopefully we remember though about how to plot a graph. We have y values, x values, how they work, and how an equation will determine that graph, because we want the points that satisfy that equation.
And Sammy points out, you got to assume that everyone has all their legs, because it's possible for someone to lose a leg, and then this little equation here wouldn't be accurate.
All right, Sammy, I'm watching you. You're always thinking outside the box. All right, so we'll paste the link to join into the chat, or if you go down to the video description in YouTube, the link is there, and this is the screen that you're going to see here. So it says start activity, and let's go ahead and dive in and see what this is all about. So this is Shelley the Snail. See how cute Shelley is there?
Yes, I love this animation.
All right, so there is a 25mm height that up to the top of these logs. And
oh, and I can click on them and try and fill it up.
You can, that's right. So there's lettuce over on the right, and Shelley's trying to get to the, no!
That is adorable. Did you see how the eyes got big for just a half second, and then it was like, oh, back in the shell I go. There's a bit of a bump.
Poor Shelley.
I will have to try again.
Okay, Science
So
Mom.
How do I take blocks? Oh, and I can just click on them to take them off.
You can click on them to remove them.
Oh, look at that.
Okay.
I think maybe I wasn't supposed to get it quite so quickly.
Well, let's see. I don't know.
It looks pretty even to me. Yes! Shelley is making it across.
Go, Shelley. Go, Shelley. Go, Shelley. Yes.
Oh, that's adorable.
Nice. Okay, so were there other combinations? So you found one combination that worked.
And now I need to know what happens if there's a drop. Okay, good. Shelley's a very smart snail. Shelley did not fall down the hole.
That's right. Ooh. So Alley Cat has a suggestion for us in the chat. It said do 8 purple blocks and 3 red blocks.
Ooh.
Oh. Okay.
Whoops.
Remove one of those purples.
Ah! I pushed the wrong button. There we go.
There we go. So.
There, now it works. So I had just 2 purples and the rest red, and that worked. And then if we have 3 red, the rest purple, we know that works. How many combinations are there?
Yeah, so that's a real good question. My guess is as a class, we'll actually be able to come up with all the different combinations. Now, I have a different question for you. Does it matter whether we do the red blocks first or the purple blocks first, or if we mix them?
Oh, that's a great question. I do not think order matters. And I'm seeing in the chat, Miriam says that 7 red and 2 purples worked. So,
okay. Which I think is what you had done the first time.
Mm-hmm. I'm seeing several different combinations of blocks that are all working, and I don't think the order matters.
I saw 5 of each suggested. Maybe we try that one real quick. Okay, and you're right. The order doesn't matter, and that's because that's called the commutative property of addition. It really doesn't matter what order. If I do 3 plus 7 or 7 plus 3, I can choose the order, and here we're just adding those together. So you're right. It doesn't matter. Cool. So there's another combination.
And 5 and 5 worked. Nice.
Ooh, Sammy says just do 1 red and the rest purple. Ooh, and Melanin saying the same thing?
Yep.
Okay. Let's try it. It's really satisfying to watch this animation, and it's also satisfying when it fails, but
I think it's pretty cute the way that Shelley goes back into the shell.
yeah.
Nice.
Shelley is a happy little snail. Okay, so now we're on to screen 2. So in the upper right corner you can navigate, and in this case we have a 36 millimeter height. So I'm reading along the left side here, and we are already given some stacks of 4 millimeter blocks, which is different than the size we had on the previous screen. And we are asked to fill in the rest using 2 millimeter blocks. And we have to get this thing all the way up to the top. And notice each stack is going to have to be a little different, but as I click in here, it shows me which stack I'm working with. So we've got the number of 4 millimeter blocks in this column, number of 2 millimeter blocks in this column, and we could just enter a number like 12, and yeah, we could totally try it. It didn't work, and I obviously didn't fill in the rest, so that didn't work, but I want to give you 3 minutes to work through this screen, and if you get through this one, I want you to go to screen number 3, because it's time to investigate. Do we have the tools to actually answer this? If nothing else, we could always try guess and check, although I hope you'll actually try to reason it out as you go.
And I want to point out real quick, if you're not aware, you can use this to draw on here. So you could try and estimate, like, okay, how many blocks am I going to need? That might be useful.
Yeah.
All right, we'll give you some time to work on it, and then we'll be back.
Good luck.
Nice work. I see Seth and Malachi, Connor, Heather, Will, Debbie, Joshua, Iris. Way to go, Robin and Cora and Krista. Space Cat has got this as well, so lots of you have completed this already.
Okay, so we need a total height of 36 millimeters, and if we were only using the 2 millimeter blocks, I think we could just divide 36 millimeters by 2 millimeters, and that would give us the number that we need. However, in this case, we're starting with 1 block already, so we don't need the full 18 blocks because some of that distance is already accounted for. So if I take away the 4 millimeters from 36, that's 32 millimeters of height that we need right here. So we need 32 millimeters of height, and to get that, I need 16 2 millimeter blocks. So we just test it out, and it works. So we can figure it out from scratch, although guess and check will also get us there in this case. We can try it. Okay, but what about for the next one? Now we need to go a height of only 28 millimeters. So 14 times 2 is 28, so yep. 14. And then we need to go 24 in height. Okay, so that would just be 12 times 2. And at this point, I did notice some people in the chat pointing out there's a pattern. Do you see the pattern in that right column?
Ooh, we're going down by 2 each time. 16, 14, 12. I bet we're going to be 10, 8. I do see a pattern.
All right. And yeah, so each time we step up 1 in the X column, we're going down 2 in the Y column. Ta-da! Go, Shelley.
And that makes sense because each of those blue blocks is like 2 of the purple blocks.
Yeah, exactly. So you have to either replace 2 purples with 1 teal. Is that what color you would name that? Right. Very good. On to the screen number 3. All right, so Shelley has to cross this gap. So 36 millimeters was that height. We have the 4 millimeter blocks and the 2 millimeter blocks. But now we're jumping to values of this table that we didn't see before, and we no longer have Shelley moving across the screen. We don't get to see them actually get built. Instead,
we have a graph.
A graph. So along the horizontal axis, I'm seeing 4 millimeter blocks, the number of those, and then for the vertical axis, number of 2 millimeter blocks. And really, this is the exact same question as on the previous screen, just with slightly different numbers of 4 millimeter blocks. Okay, so let me just check the dashboard. All right,
so it looks like about half of the students have done it, but half need a little bit more time. So okay. Let's put...
I want to throw another minute on the clock, and let's see if you can figure out these ones. But yeah, the pattern isn't going to continue quite the same way because of the X, the number of 4 millimeter blocks, 0, 6, and 7, that one's not following the same pattern. So with that being said, good luck. I'll give you another minute. Okay, so as I look at my dashboard, yeah, I still see some progress, although we're not all the way there, and that's okay. So we had 0 4 millimeter blocks for our first row there. So if there were no 4 millimeter blocks and you only had 2 millimeter blocks,
and you need to get 36 millimeters high.
That's right. We need to get a total of 36 millimeters high.
36 divided by 2 is 18.
That's exactly right. So 36 divided by 2 is 18. Yeah, so if I just write that out, 36 divided by 2 is 18. So that's the distance that we had to cover, and that's the size of each block. And I could put millimeters on both of those, and Okay, so 18 is what we think is going to work. Okay, then what if there were 6 blocks?
You know what I see?
6 4mm
Six
blocks.
4mm blocks. I see a line here. And I think if I draw this line down, that might be a good way to just kind of double check my answer.
Ooh, and maybe even to get the answer, if you have a really accurate line, you're thinking we might even be able to just eyeball the line. Let's see. So when the number of 4mm blocks is 6,
then we should have 6 2mm blocks.
Okay, so you
this
think
matches over here.
Okay, so you're thinking that's the point 6, 6. Okay, I like it.
Ho ho ho!
Wow.
I feel like I just discovered a superpower.
Okay, let's see if it works again. Let's try it.
All right, so 7 right here. That looks like it matches with 4.
Okay. And if we were to go back to the previous screen, we'll actually see that that is continuing the pattern. So I like it. So notice that the check was kind of built in for us. We said that there were 0 of the 4mm blocks and 18 of the 2mm blocks for a total of 36mm.
Oh, so you could just use the equation.
That
Add
equation.
them up.
So just like when we opened the class today talking about the number of legs that were in your house with people and dogs, well, we're using that same reasoning here, except it's not legs, it's millimeters that we're covering with different size blocks. But yeah, so if there were 6 4mm blocks and 6 2mm blocks, that covers 36mm. If there are 7 4mm blocks, 4 2mm blocks, that's also 36mm. It works both ways.
Yep. Good job, Isabel and Heather. Are we ready to go on to the next screen now?
Yeah, well, I'm actually a little curious. I wasn't watching carefully, but how many of you actually drew the line and figured it out that way versus doing it just by thinking out the numbers, crunching them in your head? Because I thought that was pretty clever of you to come up with that one, Science Mom, and definitely a few others were thinking along the same lines. So, yeah, let's go to screen 4.
Nick points out it's nice to have both approaches. Got the equation and you got the graph. You could do it either way.
Which is...
And Sammy did the line approach. Nick used both strategies.
Ooh, yes. It's so nice to have a backup, something to confirm what we've done.
Nice.
All right, so now we're on to Tyrone's work from that previous screen, and Tyrone wrote it interestingly. So he said usually there would be 18 of the 2mm blocks.
That's if you're not using any of the bigger ones.
To cover 36mm. But then that 18, well, you would have to subtract 2 of those for each 4mm block that replaced them.
So every time you use one of the blue blocks, you got to take 2 of the purple ones out. I'm following.
That's right.
Yep.
If those colors were right. I don't remember even the color scheme, but yes. All right. So we're given some information here, and notice we're calling the number of 4mm blocks X and the number of 2mm blocks Y, and that's because a horizontal axis and vertical axis usually get named X and Y. Okay. And the challenge on this screen is to write out an equation for the number of 2mm blocks Y needed for any number of 4mm blocks X. And they start us off with Y equals, but we have to then figure out, well, what's an equation that would actually work? And so there had better be an X in the expression that we write. It'll be Y equals something, but it's going to depend on the number of 4mm blocks. So it won't be like Y equals 7. There's got to be some X in that expression. And I want to give everyone a minute, and my hint is going to be to look at that table. The table will help you to discover the pattern. So I don't want to be any more specific than that, but everything you need is there. Okay, so we have y equals, do you see the pattern, Science Mom? Do you see how my table hint played into this?
Yes, so we have 18 minus 2, and then this value right here equals the x value. So I said, aha, it's going to be 18 minus 2 times x.
So you were saying up here, these are all almost identical expressions. There's only one thing that changed between them, and that was what we were multiplying by the 2, and that number was always the exact value from the x column.
Yep.
Okay, let's check your work and see how you did.
Straight line.
Nice.
But that's not the only answer that I saw our students do. Cora had a different approach, and we had a little bit of variety.
Yeah.
And we should just ask, does it matter if I put parentheses here? Because some students put a parentheses around the x, or they put a multiplication symbol in between the 2 and the x. Does that matter?
Okay, excellent questions. And the convention is that if you put two things next to each other, you're multiplying them. So if you put a variable next to a number, you're multiplying them. So they're all equally good. If you put the 2 times x, or if you put the parentheses around the x, then they all mean the same thing.
Yep. Nice job, Miriam and Nick Official in the chat say, doesn't matter.
Yep.
You can do it either way.
And typically, I'd just leave off the parentheses unless they add something special, because we like to write the bare minimum that we need to. But sometimes, if there actually is a more complicated expression in those parentheses, then they're indispensable. On to screen 5.
Bloop.
Okay, so we have that same relationship, but we're seeing it in two different forms here. On the left, so we had 4x plus 2y equals 36, because we were trying to just add up all the way to 36 by blocks of size 4, blocks of size 2, and somehow it had to work out. But over here we have y equals 18 minus 2x, and we're saying that this is the same relationship represented two different ways, but how do you see that the equation matches the relationships? Are they really equivalent? Like, what does that actually mean? So I'm hoping you can type in your thoughts. How do we know that these are equivalent expressions? What do we think? So what does it even mean for an equation, two equations to be equivalent expressions? And one of them is a little more satisfying than the other when we get to see the full animation that's happening.
And it's true, this one was a lot more fun to watch, to see the snail actually crawling along, right?
Yeah.
But in terms of the equations and the numbers, Miriam says, I just simplified it, and then I see CV has a little equation showing the thinking, saying multiply by 2.
Ooh, okay, so that we're actually just getting into some algebra by doing some balanced moves. Okay, I like that thinking. So if you could manipulate one expression and turn it into the other one, then that would be a way of saying that they're equivalent. I like that a lot. That's exactly what we're going to do on the next screen. And I would just add that we know that two equations are equivalent if their solutions are the same. So on the graph, that means that they share the same points. So the x and y pairs that make one equation true are the same as the x and y pairs that make the other equation true. That's what makes them equivalent expressions. And they both have their uses. So sometimes one's going to be a little easier to work with than the other, but I love that we can come up with different ways of looking at the same expression.
Me too. Alicat says you can fill in a value for x, just pick a number and check, and it'll be the same for this one as it will be for this one.
Yeah, you get this exact same y value to go with each x value. I like that a lot.
Yep.
All right, so on to the next screen, and here we're actually going to be doing some algebraic manipulation. On the left half, if you can do this on your trackpad on your computer, you could actually show your steps, or on the right, you could type it out. So you could try to put into words what you were doing, and I
was going for a smiley face, but I made my face too small, so that doesn't quite work. But yes, you can draw on this one here, or you can type and explain your thinking here, either way.
That's right, and sometimes I like to type in sentences, but other times, if you click here, you can go to math mode, where you can also type in some thinking. But try to put it into words. How do we convert the equation 4x plus 2y equals 36 into the expression y equals 18 minus 2x, and you're only allowed to do legal moves, balanced moves that keep the equation balanced. Remember, think of it like a scale. Whatever you do to one side, you better do to the other side, otherwise you'll be out of balance.
So if you multiply or divide one side by 2, then you need to multiply or divide the other side by 2. You got to treat them the same.
Exactly. So take a minute, see if you can work on this. And this is a skill that we normally would have practiced a bit more before this lesson, but I just want to see what you can come up with. Good luck. All right, that wasn't a lot of time, but let's dive in and see how you might do this one, Science Mom.
So I was thinking the exact same thing that Leva was thinking. We subtract 4x from both sides, and then divide both sides by 2 to get the y all by itself.
Okay, so you're subtracting 4x, and what do you get when you subtract 4x from both sides?
So then we get 2y equals 36 minus 4x. But you know what? I could just, yeah,
I like this.
that. 36 minus 4x. And
it's always hard with the trackpad. But
it is challenging to write with the trackpad. And now we're going to divide both sides by 2.
Okay. And I like how you said we're dividing each side by 2. We can't just divide bits and pieces by 2.
We have to divide everything by 2.
Okay, so you divided by 2 and then you broke it up. So
Yeah.
Combine 2 steps in one. All right, and what did that leave you with?
And then that leaves us with y, because 2y divided by 2 is just going to be y.
Okay, the 2's divide out.
And then 36 divided by 2 is 18. And then it's going to be minus 2x, because 4x divided by 2 is 2x.
I like that.
And that's what we wanted.
Okay, so great job, those of you who went that route. There was another route that I saw students using. So Sammy and others decided that they wanted to just start by dividing both sides by 2. Because they knew eventually they didn't want 2y, they wanted just y.
Yep.
So in that case, if we start out by dividing by 2, so, and I like how you typed out your thought process, several of you. So divide both sides by 2. So in that case, we're going to get 2x plus y equals 18. Okay.
Ooh, and now we just subtract 2x from both sides, and we're going to get the same answer.
Good.
You can do it either way. There are multiple ways to do it.
That's right. So then if you subtract 2x from the left side, you just have y, and on the right side, you have the 18, and then you have to subtract 2x, and boom.
Yep, nice job. Space Cat chose that approach, and so did several others.
Yeah. And you don't always have to write out full sentences, but it sure is nice when you are able to do it, especially if you're communicating that idea to someone else. But yeah, we definitely want to practice doing neat work whenever possible. All right, so we actually could show that they were equivalent, and this particular skill that we did here, we're going to get more practice on it, but we always do the same thing to both sides. We wanted to get y by itself, so that kind of led what we did. Anything that wasn't a y, we had to undo it either by dividing by something or adding something.
It's a card sort. I love
is.
card sorts, and I always like to start them by just sort of organizing it visually.
All right, so on this particular one, we're supposed to match each graph with the 2 different equations, and there will be 2 cards left over. Now, typically, I would give us a little more time to work on this. However, I want us to make more progress because there's a practice screen up ahead.
There's a real fun activity coming.
Yeah, or yeah, something that I think is a little more exciting than just the card sort. So let's actually do this one together right now. So we have to figure out which equations go with which graph. Maybe you remember this really well. Remember how we had our points, or well, slope-intercept form, like y equals mx plus b. So that equation is just going to show up over and over again for every math class for the rest of your life. It's super important. But a lot of these equations are not in that form. So can we actually figure them out without, if we were rusty? Well, I think we can.
I think it might be helpful just to say, okay, when we have 0 here, the value is 4. Maybe we can use that to match some of them up.
You read my mind, science mom. That's right. So the point 0, 4 has to be on this line, right? So let's test it. If I plug in 0 for x and 4 for y, and let's just look at one equation at a time. If I plug in 0 for x and 4 for y, I would get 4 equals 8 minus 0. Nope.
That is not true.
On this one, if I plug in 0, ooh, that one actually works.
I would get 4 equals 4,
okay,
and that is correct.
So I'm going to put it up here. It's a suspect. It might work. Okay.
But can't we just match it right now?
Well, no. Just because you know one point doesn't mean that the whole line matches, right? So to test it, we would maybe look at the other point. So we have 8, 0 is this point down here. So if I plug in 8 for x, then and 0 for y, I would get 0 equals 4 minus half of 8.
Which is 4.
That one does work. Okay,
Yay.
but you have to test 2 points. You can't just check 1 point.
Okay, good to know.
Okay, this one didn't work. For this one, if I plug in 0 for x and 4 for y, nope, doesn't work.
And I just want to remind everyone real quick, if you'd like to pause the video and give yourself more time to work on these before moving forward, you can always do that. You can always pause the video so that you have more time.
Okay, so if I plug in 0 for x and 4 for y, okay, that one also doesn't work for this rightmost equation. All right, or graph. If I plug in 0 for x and 4 for y, ooh, that one does work. And if I plug in 8 for x and 0 for y.
So 8 for x would be 2 times
2
8
times
is
8
16.
Plus 4 times 0 is still 16.
Equals 16, so that works.
All right, so that one works. And then this one doesn't work for that one. Okay, now for this graph, we have different points. 0, 8.
When x is 0, then y should be 8.
Okay, so this one actually works. And also, if I have 2, 0, so if 2 is equal...
If x is 2, then
sorry, 0 is equal to 8 minus 4 times 2. Yep, that one's true. And then, what else do we have? So tell that guy's bad news. Okay.
And another little tip for you, having paper and pencil in class is always a good idea. Matt Dad's going through this fast because there's a fun activity we want to be able to do live next.
We'll run out of time otherwise, but okay.
But having pencil and paper and just writing it out, plugging the values in and solving would be a good idea.
So if I plug in 2 for x and 0 for y, I do get
16 plus 0 equals 16. That's a true statement.
Good. And if I plug in 0 for x and 8 for y, that one works. All right, good. And then these two, it turns out, are just not going to fit either one. So I know I rushed through this screen, but I'm sorry about that. We want to move on to the next screen. No more apologies. Because we have reached the repeated practice screen.
Ooh.
All right, so on this one here, I actually want to do this first one together. Shelley needs that lettuce, so hungry. The sun is out. Shelley needs the lettuce. All right, but we are told 6x plus 2y equals 34, and I want to solve this one in front of you, and I think this is the same problem everybody gets.
For the first one.
For the first one. So I'm going to write it down, and then we'll move over. So we had 6x plus 2y equals 34, and we need to solve for y. In the end, we need y equals something. Okay, so how do I get y by itself? Well, I have to undo whatever's happening to y, and typically I start with what's happening most indirectly. So this adding of 6x How do I undo a plus 6x?
You subtract 6x.
Okay, and I'm going to do it to both sides of the equation. On the left, I'm just going to be left with 2y, and on the right, 34 minus 6x. Okay, now how do I undo a times by 2?
Divide everything by 2.
Because we're trying to get y all by itself. Okay, so if I divide by 2 on the left, I'd better divide by 2 on the right. So then I get y is equal to, and then what's half of 34? 34 divided by 2 is 17, minus, and half of 6 is 3 times x. So boom.
So that's our equation, and the instructions say to rearrange the equation and then complete the table all at once.
So let's enter what I have typed. Y equals 17 minus 3x.
And then, do we need to fill it in to complete the table?
Just check your work.
Oh ho ho, it autofills it for us.
That's the beauty of a formula, is that it will actually answer all the questions at once. We do have to do the work of plugging it in, but once we found that relationship, then it's just a little calculation. The big thinking is done.
These repeated challenges are a lot of fun. We're going to put several minutes on the clock so that you have time to do this practice. And remember, piece of paper and pencil. You're going to want to have that because when we hit try another, then Shelley is back with a different set of blocks and we have a new equation where we need to get it in its form where it's y equals and then everything else on the other side.
All right, so thanks everybody for chiming in. Good luck. We'll give you 3 minutes. See what you can do in that time.
So So, some students have done quite a few, others have just completed one. We really want you to have just a little bit more time to practice.
So I'm going to show one more example, and then I'm going to give you one more minute to see what you can do. So, so Cora and others actually even came up with a shortcut. They noticed that up here, so we got 2x plus 4y equals 26, that we would have the 26, and then we would have to subtract the 2x from both sides, and then we would have to divide that whole thing by 4. And then we could just leave it in that form, and we then have y by itself.
Oh my goodness. That's pretty clever.
So we kind of got away without simplifying, and yeah, absolutely, that helps Shelley. So what did I do there one more time? I just subtracted 2x from both sides and then divided that whole expression from both sides by 4, and we were able to get there. So one more minute, you can do it. All right, so on this one here, we've got 3x plus 4y equals 40, Science Mom. So,
and I really like to be able to write it out. So I'm going to subtract 3x from both sides.
okay,
And then that's going to give me 4y equals 40 minus 3x.
nice.
And now I need to divide everything by 4. So I divide this side of the equation by 4, I divide this side by 4, and that gives me y equals 40 divided by 4 is 10, and then minus 3/4 x. And is it okay to have a fraction or a decimal here?
Absolutely.
Absolutely. Absolutely. I saw a couple questions about that earlier. That is just fine.
Yeah, and if you prefer to convert it to a decimal rather than keeping the fraction, no harm there. So 10 minus 3/4 times x, and test it out.
There we go.
Go, Shelley. Excellent.
And Sammy asked if we are going to do this lesson again when we have the full algebra class.
Yes.
We will be.
All right, for the lesson synthesis, how would you convince a classmate that these 3 cards represent the same situation? So on screen number 9, yeah, what would you do if you were trying to convince somebody who hadn't seen this lesson that we actually ended up with the same situation? 2 different equations, right? You look at them, they're like, very different.
And while you're thinking about that, I just have to give a couple quick shout outs. Good job, Will, Kat, Miriam, Aaliyah, CV, Robin, Cora, Space Cat, Eli,
Seth? Yeah.
Iris, Nick Fischel. We've got lots of students who did a lot of practice problems. Well done.
Yes. Okay, so let's see.
We'll give you a minute to write.
All right, we're gonna go over by a few minutes, but yes. Okay, seeing some great responses here. It looks like most people are trying to convert one equation into the other, and most people are saying solve for y in the left equation, 2x plus 4y equals 16. And as long as you're using balanced moves that keep the exact same solutions, then what you're doing will work out. And when you get y all by itself, then you have 4 minus 1/2 x. That's one nice thing about that form of an equation, is that there's a unique way of writing it if you solve for y. But if you don't solve for one variable, it turns out there are infinitely many ways of writing an equation for the same line, same situation.
Cora had a different idea that I loved. If you plug in the same numbers for x and y in both equations, you'll get the same points on the graph.
Ooh,
so that would be one way to show them. And then good job to Iris and Levitt, just explaining how to do this and writing out steps for how you could show that they're the same.
Yep.
Nice work. CV says get a calculator. Calculator helps if you know how to use it, right?
That's true. All right, I do have a random thing here. I like AI art engines, and so I asked both Midjourney and DALL-E 3 to make the same piece of art. I just asked for a racing snail.
Let us know real quick which racing snail you like best. Which one is going to be the winner for our class? 4
on the left are from Midjourney, the 4 on the right are from DALL-E, and I've got them numbered 1 through 8. And do you notice something funny about these, Science Mom?
Yeah, some of them have anatomical errors.
Yes, so DALL-E gave them the eyes up top, but most of them have eyes down below that are covered by goggles.
Yeah. And then Midjourney is, some of them have extra antenna and tails and things. Carly votes for 8. Eli says DALL-E. Sammy says number 4. Nick Official says 8 looks epic.
My personal favorite, I like number 6. Number 6 has like racing stripes. I'm just getting this racing vibe.
Miriam votes for DALL-E. Cynthia says Midjourney for aesthetics and DALL-E for the prompt, following the prompt. Robin says 4 or 6. We've got votes for 4 and 8, 3 and 8 from Melanin. Yeah, it's kind of hard to. Heather votes for 6.
They definitely had very different styles.
They did.
In this case.
I think it's between 4, 6, and 8. We kind of declared a 3-way tie for that one.
That's right. Well, it was all better than I could do. That's for sure. Right, which equation is equivalent to 6x plus 2y equals 12? We have 4 options there. Can we figure it out? So we're already several minutes over, so let's go ahead and figure it out together. I'm going to copy it down.
Shelley was definitely the inspiration for that Midjourney prompt, and then I think that DALL-E was inspired by Turbo, because it was definitely more of like a cartoon style. Whereas I think Midjourney was taking more like real snails.
All right, so we have y all by itself in all the answers. So let's do it. Let's solve for y. So I'm going to subtract 6x from both sides. Not the only way to do it, but I like it. So on the left, the 6x's cancel out. They subtract right out of the problem. We have 12 minus 6x. And then from here, how do I undo times by 2? Well, I would divide by 2. And I do the same thing to both halves of the equation.
So I saw Nick Official did that exact step on the scratch board.
So I get 12 minus 6x all over 2, or if I can cut each thing in half individually, half of 12 is 6, and half of 6 is 3, so I get 6 minus 3x, which is one of the options. So go ahead and select it.
6 minus 3x, there it is. Nice work, everyone.
That's right, we already showed our work here. So on this last screen, how well did you understand the math of this lesson? How did you feel about the lesson? You can mouse over and select whatever describes your level. It's just a way of giving us some feedback so we know what you understood. On this particular lesson, it was kind of jumped into the middle of a unit. So if you didn't understand everything, definitely don't feel bad about it. It was a lot to cram into one session, but hopefully at this point in time, you're feeling a little bit better about how the graph and the equation of the line match up, what a solution of an equation is.
And this is a lesson from the first unit of our algebra course. So this is a lesson that if you take algebra with us, we will be doing again after we do some practice with reviewing equations and graphs to strengthen your knowledge.
That's right, and with more practice, you'll get better at solving these things, and that repeated challenge screen by all means go back to it, see if you can complete more of them.
Yep, and then of course, you know, whether this lesson was a challenge or not, a lot of it depends on what, oh, sleepy puppy, what math you've had before and how much practice you've had. But the more you practice things like this, the easier it gets.
All right, everyone, thanks for joining us. Work hard, grow smart, and we'll see you next time.